Okay, so this is the last video on the fuels topic, and we're going to be looking at cracking. I've drawn out a hydrocarbon. It is an alkane. I know it's an alkane because I've only got single bonds, and if I were to count up all of my hydrogens, I would see that I have got 18, which fits the general formula of CnH2n plus 2. So I've got double the amount of hydrogens plus 2. So this is it's one of my alkanes, and it's a relatively long alkane with 8 carbons in a chain. And what cracking is when you take a long hydrocarbon and you break it down into smaller hydrocarbons. And the reason you do this is because smaller hydrocarbons are more in demand. They're more in demand because they're more useful and there are less of them. So we don't have enough of them to meet the current demand. Therefore, you take your long hydrocarbon, which are less useful, and you break them into smaller hydrocarbons. So if I wanted to break this hydrocarbon, I would need to heat it, really high temperature, and then pass it over a hot catalyst. And when I do that, this hydrocarbon is going to break. Now, it could break in any number of places. I'm just going to say that it's breaking here, between these carbons here. But it could break any number of places. And we need to look at the products when I break it. So I'm still going to be drawing my 8 carbons, but instead of having 8 of them in a row, I'm going to have 1, 2, 3, 4, 5, 6 of them in one product, and then I'm going to have 2 of them over here in a separate product. So I've still got 8 carbons, but I've got 6 and 2 instead of 8 in a chain because I'm breaking it. And now I need to fill in my hydrogens. I've only got 18 hydrogens on the left-hand side, so I can only put in 18 hydrogens on the right-hand side. I'm going to start here with this longer molecule. I'm going to start putting in my hydrogens. I know carbon has to have 4 bonds. The carbon here only has got 1, so I'm going to be putting in 3 hydrogens around my first carbon, so it's got 4 in total. My second carbon has 2 bonds, so there's only room for 2 hydrogens. Then I can put 2, 2, 2, and then my carbon at the end has only got 1 bond. There's room for 3 hydrogens, so I'm putting in all of those hydrogens. So far I have got my 6 carbons there, and I have drawn 14 hydrogens. That means that I've only got 4 hydrogens left for the molecule at the end. So I put in my 4 hydrogens, 1, 2, 3, 4, and what you will see is that by putting in those 4 hydrogens, my carbons are still not happy. Each carbon only has 3 bonds. It wants to have 4, but I've got no more hydrogens to put in. So instead, what I'm going to need to put in is a double bond. So I'm forming C2H4. So I've started off with a long alkane. I've carried out my cracking reaction. I've ended up with a shorter alkane and an alkene. How do I know that these guys are both alkanes? They both fit the general formula, CnH2n plus 2. So I've got double the amount of hydrogens plus 2. So double will be 16, plus 2 is 18. Double will be 12, plus 2 is 14. So they fit the general formula, and I can see from drawing them that there's no double bonds in sight. With my alkene, the general formula is CnH2n. I've got exactly double the amount of hydrogens, and I've got a double bond in there. So I'm taking a long alkane, breaking it to give me a shorter alkane and an alkene. Why do I do this cracking reaction? Because these shorter alkanes and the alkenes are more useful than the big long chain. We don't have enough of them. We want more, so we carry out this cracking reaction. So it's here in your notes for you as well. Okay, you've got lots of different sizes. The small ones, more useful. So you take the long chain, you break it down. In order to do this, you need to heat to vaporize it. You pass the vapor over a hot catalyst. And why? Because the demand is really high for these smaller hydrocarbons. So you can be asked what it is. You can be asked for the conditions, and you can also be asked to complete these little reactions, which I have here. Well, actually, we'll do this one. So. Oh, crap. If we look here at question number 7, okay, so I've given you a long hydrocarbon on the left-hand side, and then you're breaking it down into a smaller hydrocarbon, and you need to fill in the products, okay? You have got to have the same number of carbons and hydrogens on each side. So if I look at this, I have got 8 carbons on the left-hand side. On the right-hand side, I currently have 3 multiplied by 2, 6 carbons, which means the other product must have the remaining 2 carbons. C2. Okay, 8 carbons on the left, 3 times 2 is 6, 6 on the right, plus 2, now I've got 8. If I look at my hydrogens, I've got 18 on the left, I've got 3 times 4, I've got 12 currently on the right. I need to have 18, which means I need another 6. So that must be my missing product. All right, if I do the next one, I've got 10 carbons on the left, on the right I've got 3 times 2, I've got 6, so I need another 4 carbons on the right hand side. With my hydrogens, I've got 22, and I've got 3 times 4 is 12, which means I need another 10. Okay, so when I add these up, they should perfectly balance. With C15, I've got 15 carbons on the left. I've only got 8 so far on the right, so I'm going to have C7. 32 hydrogens on the left. 4 4s are 16, so I need another 16. So it's C7H16. Okay. Press pause, maybe do the other 2, D and E, for yourself, and then press play to see the answers. So for the next one, I've already got 12 carbons, 10 there, so I need another 2, and then 26 on the left. 5 4s are 20, so I need another 6. And then the last one, I've got 9 carbons, I've currently only got 6, so I need another 3. 20 on the left, 3 4s are 12, and I need another 8 on the right. So with those cracking reactions, you just need to make sure you end up with the same number of carbons and hydrogens on the left and on the right. And so a few more examples there, which are actually a little bit easier. When you've got those big numbers, make sure you're multiplying each time when you're calculating the number of carbons and hydrogens that you have. The very, very last thing on the fuels topic is just a little bit about hydrogen. And they ask you why hydrogen is a good fuel, just hydrogen gas itself. So remember, what a fuel is something you burn that releases energy, okay? And hydrogen gas, if you burn it, it releases energy, therefore it can be used as a fuel. When you're burning hydrogen, you're combining hydrogen with water, with oxygen, because burning is always reacting with oxygen. If you react hydrogen and oxygen, you just form water. So the only product is water. You're not producing any carbon dioxide, which is a greenhouse gas. You're not producing carbon monoxide, which is poisonous. You're just producing water vapor, okay? So that's a massive plus point for using hydrogen as a fuel. It's also very easy to ignite. Easy to light on fire, easy to burn. You get lots of energy when you do this reaction. It's an exothermic reaction, and it releases lots and lots of heat energy. And it is a byproduct of cracking. So it's easy to make hydrogen, in other words. So this question here asks you to evaluate the advantages and disadvantages of using hydrogen instead of petrol. Anytime you're asked an evaluate question, you need to give the advantages and disadvantages of both and then give a conclusion. It doesn't matter which side of the argument your conclusion is on, you just need one conclusion. So I've written about petrol first, okay? So petrol is a hydrocarbon. Remember, it's one of your fractions of crude oil. That means when you burn it, you are going to be producing carbon dioxide. All hydrocarbons produce carbon dioxide and water when they are burned. Carbon dioxide is a greenhouse gas, okay? So that's not good. So actually, if I just show you, if I made up a hydrocarbon, not with highlighter. If I made up a hydrocarbon, C3H8, and I reacted that with oxygen, okay, when you've only got hydrogen, it combines with oxygen to form water. Here, I've got hydrogen, which combines with oxygen to form water, but I've also got carbon, because it's a hydrocarbon, not just hydrogen, so that combines with oxygen to form CO2. So any of your hydrocarbons will form CO2. Hydrogen only produces water, so that's better for the environment. Petrol, though, it's a liquid at room temperature. It's easier to store a liquid than a gas. Remember, if I drew for you your particle diagram, so you got your solid, you got the liquid. Oh, these are awful. You've got your liquid and then you've got your gas. Particles in a gas are much further away from each other. Gases take up more space. So they're difficult to store unless you put them under really, really high pressure and push those gas particles close together. But that can be dangerous because they're liable to explode. So much easier to store a liquid than to store a gas. Okay, so it's difficult to store hydrogen in large amounts. So that's an advantage and disadvantage for each of them. Then you can say for both of them, they're both fuels that are easy to ignite. They both reduce lots of energy. But then overall, I've gone with hydrogen. I said it's better for the environment, so it should be used over petrol. But if you could say at the end, I'm going to go for petrol because it's easier to store and you think that's the most important thing, it doesn't matter as long as you pick a side and write a sentence. That's all you need to do for your an evaluate question. So that's the end of the fuels topic. I think it's a relatively straightforward topic. There's quite a bit to learn. But in terms of the chemistry, there's nothing that difficult in it. So it is a topic that you should all be targeting as potentially something that gives you full marks.